So let's take a closer look at lists now. We said that lists are mutable objects. So if we have a list called list 1 whose values are 1, 3, 5, 6, and then we assign list 1 to the name list 2, then we said that both list 1 and list 2, in this case because lists are mutable, will be pointing to the same list 1, 3, 5, 6. So now if I take the position 2, which is this position, and replace it by the value 7, then clearly list 1 is 1376, but because list 2 and list 1 were pointing to the same object, we have that list 2 also has the same value 1376. On the other hand, if we made this change in a more roundabout way, so what we did was we took this list and then we first took its slice 1, 3, okay, from 0 up to position 1, not 2, so I get 1, 3. Then I insert a 7, and then I take from position 3 onwards, which is 6. Then I also get 1376 in list 1. But on the other hand, because I used plus, what I've done is I've created a new list, okay, and therefore list 2 has not changed. In this case, list 2 remains 1356. So in other words, concatenation using plus results in producing a new list. So let's check this in the Python interpreter. So if I say list 1 is equal to 1357, for example, or 56, and I say list 2 is equal to list 1, and then I just change the position 2 of list 1, then list 1 and list 2 are both 1376. On the other hand, if I say list 1 is equal to 1356 as before, and list 2 is equal to list 1, and now I change list 1 in this slice plus concatenation way. So if I say take the first two positions, then put a 7, and then take the rest of list 1. Okay, so now list 1 is again 1376, but list 2, which was pointing to list 1, is no longer pointing to list 1 because the plus has created a new list, right? And so the new list is not the same as the old list, so list 2 continues to point to the old list, so it's 1356. So this is an important point that one has to keep in mind regarding mutability. If we start reassigning a list using plus, we get a new list. This also applies when we do it inside a function. If inside a function we want to update a list, then so long as we don't reassign it, we are okay. But if we put a reassignment using plus, then the list that is being updated inside the function will not reflect outside the function. So we always have to be very careful about this. Now, how would we go about extending a list? Suppose we want to stick a new value 22 at the end of a list. One way to do this is to say L is L plus 22. But as we saw, this plus operator will create a new list. So if you wanted to append a value to a list and maintain the same list so that, for instance, if it's inside a function, we don't lose the connection between the argument and the value being manipulated inside the function, this would not do. So we saw this function append in passing when we did GCD in the very first week. So append is a function which will take a list and add a value to it. So here we have said list 1 is 1356 as in the previous examples. List 2 is list 1. And now we have said take list 1 and append 12. Okay, so list 1, the way we write it is list 1 dot append, and in append we give the argument the new value to be appended. So what this does is, of course, it will make list 1 now a 5-element list with the original 1356 and a new value 12 at the end. But importantly, this is the old list 1. It's not a new list in that sense. So list 2 has also changed. Right? So append actually adds a value in place. Both list 1 and list 2 point to the new list with 12 at the end. On the other hand, if we had done it, like I mentioned, using the plus operator, then we would find that list 1 changes but list 2 does not, because as we saw before, concatenation produces a new list. So append is a function which extends a list with a new value without changing it. So append takes a single value. Now what if we wanted to append not a single value but a list of values? We wanted to actually take a list and expand it by adding a list at the end. We had say 135 and we wanted to put 6, 8, 10. Right? So we want to take 135 and we wanted to expand this to have 3 more values. So of course we can append each of these values one at a time, but there is a function which is provided which, like append, extends a list, but here this must be a list itself. Right? So list extend takes a list as an argument, append takes a value as an argument. So list1 extend list2 is the equivalent of saying list1 is equal to list1 plus list2. But remember that this must be a list. Okay, it's not a single value, it's not a sequence of values, it's a list. So this must be given in square brackets. So you must give 6, 8, 10 as an argument to the extend function. Now this is to add elements to a list. There is also a way to remove an element from a list. So this is one way to remove it by specifying the value. So we are not looking at a particular position, we are looking for a value x, and list1 remove x removes the first occurrence of x in the list. Now you may ask, what happens if there is no occurrence of x in the list? Well, in fact, this will give us an error. So you have to be careful to use remove only if you know that there is at least one copy of x. And remember, it only removes the very first occurrence. It doesn't remove all the occurrences. So if there are 10 occurrences of x in list1, only the very first one will be removed. So let's explore these things. So let us start, say, with list1. So remember from the previous lecture, we said we can take range and produce a list. So now if I do this, I have list1 is 0, 1 up to 9. Now if I say list1 dot append 12, then list1 is appended with 12. Now if I say list1 dot extend, say 13, 14, then list1 now has 13, 14 at the end, right? So this is how append and extend work. Now supposing, just for the sake of argument, I take list2 and I make 2 copies of list1. So now list2 goes from 0 to 14, with a gap of course in between at 10 and 11, again from 0 to 14. Now if I say list2 dot remove, say 5, now there are 2 copies of 5, remember, the first copy which is here at the beginning and a second copy which is later. So this will remove the first copy. So now if I look at list2, the first one skips from 4 to 6, but the second copy is still there. If I say it again, then both copies are gone because I don't have this 4, 6, and I also don't have a 5 here. Again, it's 4, 6. Now what happens if I remove it a third time? Now I get an error saying x is not in the list. So remember that remove works only if x is in the list. If it's not in the list, you get an error. Now it's important, we'll see later, that when you get an error, it also has a name. It says it's a value error. Okay, so this will be useful because later on we will find that within Python we can actually examine errors and take alternative action if an error occurs, and we can signal what type of error it is by looking at the value that the error returns. So the append function looks a little bit different from the other functions we have seen so far. We would normally expect a function append to take 2 arguments, the list and the value to be appended. So we would think that the correct way or the natural way to write append would be to say append to list1 the value x. On the other hand, what we have is this funny notation which says to list1 apply the function append with value x. Right? So in Python terminology, list1 is an object and append is a function to update the object, and x is first an argument to the function append. So in such a situation, we have an object and we then apply a function to it. So we use the function attached to the object by using the dot notation rather than passing the object to the function, which is a more normal way in which we think of functions. Right? So we will come back to this point later on in maybe 2-3 weeks from now when we look at what is called object-oriented programming within Python. So there is another way to expand and contract lists in place, and this is by directly assigning new values to a slice. So we go back to our old example, list1 is 1356 and list2 is list1. Now what we are saying is that take the slice from position 2 onwards and assign it the value 7, 8. So remember the positions are 0, 1, 2, 3. So what this is saying is take this slice, namely 5, 6, and replace it by 7, 8. So what we get is that, of course, list 1, the slice 5, 6 is replaced by 7, 8. But this slice replacement happens in place. So it's a bit like assigning a new value at a given position. If I say list 2 is equal to 7, we said that position 2 becomes 7. So in the same way, if I say that list 1 from slice 2 to the end becomes 7, 8, it changes 5, 6 to 7, 8 both in list 1, but it also does not change where it's pointing to. So list 2 also gets affected. So both of them now say 1, 3, 7, 8. Now here we had a slice of length 2 and we replaced it by a new list of length 2. So we preserved the structure of the list in terms of the number of positions. This is not required. Python allows you to both expand and shrink a slice. So for instance, you could have taken that list. Now let us say we have this list 1, 3, 7, 8, and again we want to take the slice 2 onwards, which has 2 positions, and we can say replace it by a list with 3 values. Okay, so we are saying take this list, take the slice from 2 to 3, the last 2 positions, and replace with 3 values, and what we get is the old 1, 3, and this slice has now become 9, 10, 11. So we had a 4 element list, it's become a 5 element list. So this is one way to expand a list in place using a slice. The other thing we can do is shrink a list. We can put a smaller thing. So supposing we want the list to have just one value in the positions 0 and 1. So we take the slice 0 to 2, which will give us these 2 positions. So now we have a slice of length 2, but we assign it a list of length 1. So this 1, 3 is replaced by just a single 7. Right? So now we had a list of length 5 after the previous expansion, which has now become a list of length 4 after this contraction. So with slices, you can replace a slice in place. This can produce a bigger list or a smaller list depending on what you put in. But as you can imagine, this can be very confusing. So you should be careful that you know what you're doing if you're trying to directly update slices in the list. One of the very common things that we want to know about a list is whether a value exists in a list. So Python has a very simple expression called x in L. So x in L returns true if the value x is found in the list L. Now we can use this, for instance, to make our remove a safe operation. Before we invoke L.remove x, we first check that x actually is in L. So if x is in L, then the condition will be true, and only then will we try to remove it. If x is not in L, then we won't remove x. So in this case, we are guaranteed that L.remove will not be called in an error-prone context where it will say there is no x in L. Also recall that remove removes only the first element. So we can replace this if by a while and say that so long as there is a value x in L, keep applying remove. So this will in one shot remove all the x's in L, because every time we remove an x, we go back and check if there is still an x in L. If there's still an x in L, we remove it. So from left to right, this loop will remove all the x's in L. Now there are a host of other functions defined for lists. For instance, L.reverse will reverse a list in place. L.sort will sort a list in ascending order. You can also sort it in other orders. You can look up and see how to do that. If we only want to know where an element is in L, we set x in L. But if we want to know where it occurs, then we use index. It will find the leftmost position. But again, it will give us an error if there is no x in the list. So we should first check if x is in L and then find the index of the leftmost position. Now you might want not the leftmost but the rightmost position. So there is an R index. And there is a host of other functions, and you must look up the Python documentation. There is no way that this course or any course can cover every function which is defined in Python for every type. So you do have to look up the documentation, and if you think that there should be a function which does something natural, very often there will be. So try and look it up and see for yourself how it works and try to use it. If you have a question like, what happens if I do this? Well, Python is an interactive language. What happens if I do this? Just try it out and see, and try to figure out from what you see in the interpreter how the function works, in case there seems to be some ambiguity in the documentation. But above all, don't be afraid to see the documentation. Only by looking up a documentation will you be able to learn the Python functions that you need, because it's very difficult, as I said, to say upfront every possible function that is there. So a final point regarding lists is something we talked about in passing, which is that Since names do not have types in Python, we don't have to announce a name. Names just pop up as the code progresses. So every time a name pops up, Python needs to know what value it is. So typically the first time we use a name, we have to put it as part of an assignment. We have to assign a value to it. And that value has to be something which is computable given the current names. So if we want to assign, for instance, to the name y, the expression x plus 1, at this point implicitly x must have a value, otherwise x plus 1 cannot be evaluated. So if x has not been seen before, and for the first time in my code I see it on the right hand side of an assignment, it means that I'm expected to produce a value for x, but no value has been assigned so far, and this will give you an error. So this is quite easy to spot, right? So when you write something and you see something on the right hand side and you have not seen it before, then it means that Python will flag an error, and it's not very difficult to understand why this is so. Now with the kind of list functions we saw now, it's a bit more subtle. When I say l.append v, there is no equal to sign. So it's not immediately obvious that l.append v requires L to already be having a list value. Why can't I just append v, for example, to an empty list? Well, of course I can append v to an empty list, but how does Python know that L is an empty list? Right? So Python needs to know that L is a list before it can apply this append function. So we saw this small function earlier which computes the factors of n. So essentially what it does is it takes all numbers in the range 1 to n. So I take 1 to n plus 1 so that I run through the sequence 1 to n. And if a number divides n evenly, if there is no remainder, I've used the append function now to append I to the list of factors which I will return. So now the catch with this is that when I come for the first time to this statement, the first factor, which will be 1 of course, because 1 will always be a factor, Python will have to ask why flist has the ability to append a value, because flist has never been encountered till this point. So we were careful when we wrote the code. Of course we used plus because we did not use append in that code, but it's the same thing, right? So we have to be careful to insert this initialization. So this initialization is only needed to tell Python when this first append happens that it is indeed the case that flist is of type list, and therefore the append function is a valid function to apply to this name. Without this you will get an error. So just remember that you always have to make sure that every name that you use is initialized to a value the first time, so that whenever it appears later on, the value is clear, and therefore what operations are allowed for this name are also clear to Python. So to summarize, what we saw is that we can extend lists in place using functions like append, extend, and so on. We can also assign a new value in place to a slice of a list, and in the process expand or contract the list, but this is something to be done with care. You must make sure you know what you're doing on. There are several built-in functions on list. We will see some of them as we go along and use them and describe them as we see them, but it's impossible to document all of them and to go through all of them, and it's also very boring to just list out a bunch of functions. So do look up the tutorial and other documentation which is available, which I mentioned in the earlier weeks, so that you can find out what kind of functions are available. And finally, don't forget that you must assign a value to a name before it is first used. Otherwise, because names do not themselves have types, Python will not know what to do with the given value, with a given name.